the derivative of y equals sine inverse of x. Keep in mind, that -1 here does not mean to the -1 power. Remember with the trig functions, an inverse is like finding the angle to make sine equal that. So we can't just do the power rule where we bring down the -1 because that's not the meaning. So what we're going to do instead is rewrite this problem. When we had trig, we talked about the only way to move a trig function to the other side was to add an inverse. So if I move it back, that just takes away the inverse. So what this means is sine of y is equal to x. Now this is something that we could do the derivative of, right? So derivative of sine is cosine, angle stays the same, times derivative of the inside, so derivative of y is y dx equals derivative of x is 1. So dy dx is 1 over cosine of y. Alright, what if I said I want this written without a y in it? Okay, so if I have to figure out what cosine of y would be equal to. So this is pulling back a lot of trig stuff. So if we think about sine inverse, remember when we talked about inverses? It was the very last thing we did in trig, and we talked about how they only exist in certain quadrants because it has to be 1-to-1 to have an inverse. So you can't just take the whole sine graph. So we always did a positive quadrant and negative quadrant. And so everything existed in quadrant 1, and then that was our positive. And then we would either do quadrant 2 or 4, depending on when the trig function was negative, right? Sine is positive in 1 and 2, so the inverse has to be in either quadrant 1 or 4. Okay. And whether it's in 1 or 4 would be based on if that x was positive or negative. If I drew a picture, I'm just going to go ahead and put it in quadrant 1 because I have to draw a triangle somewhere. Sine of y equals x, so that means my angle is y. Sine is opposite over hypotenuse. Okay. Could you find the missing side of that triangle? Pythagorean theorem, a squared plus b squared equals c squared. So, square root, and the side is the square root of 1 minus x squared. Alright. So, my derivative, if I told you I didn't want it with a y, 1 over cosine, that's the same as secant, right? Can you tell me secant from this triangle? Sapatella. Cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. So my hypotenuse is 1. My adjacent. we actually just proved something. So if you look in your book, the very end of this section, page 214, it has a table with derivatives of inverse trig functions. And it has all of them in a nice red box. For our purposes, probably not going to put inverse trig functions on the test. In Calc 1, we really don't use them outside of this trig function, or outside of this section. If you have to go on to take more calc, you will encounter the inverse trig functions, and they usually just expect you to know those derivatives, just like we know the derivative of sine is cosine, derivative of tangent is secant squared. So you wouldn't really work it out the whole time. It would be something you have memorized. But if you're at that point, it would just be something you studied and memorized to learn. So right now, I'm just trying to show you where they come from. When we have homework problems, you can use that table to kind of get your derivatives, but this is why. So the derivative of sine inverse is 1 over the square root of 1 minus x squared. Let's try working out another one. So it gives us all 6 in that table. Let's try to prove tangent. So what would I have to do first if I wanted to find this? Rewrite it. So that means tangent of y is equal to x. And then if we did this derivative of tangent is secant squared, angle stays the same, times derivative of the inside, derivative of y, come on, dy dx, equals derivative of x, 1. So dy dx is 1 over secant squared y. Okay, let's set up a triangle. We're really just always going to do these in quadrant 1. The other quadrant would come if the variable were negative. If tangent of y equals x, it means my angle is y. SOHCAHTOA, what is tangent? TOA, opposite over adjacent. So this would be x, and this would be 1. Okay. So now, if I wanted to find my missing side, you know, a squared plus b squared equals c squared. So my missing side is just the square root of 1 plus x squared. Now what? Can we do secant somehow? This is 1 over secant squared. So secant is hypotenuse over adjacent. So that would be the square root of this over 1. So it's just the square root of 1 plus x squared. And if you square root, it drops. So we get 1 over 1 plus x squared. So we just proved the derivative of tangent inverse. Okay, and we can do all 6 trig functions the same. We start with their inverse. We go ahead and solve switch it around. So if it were cosine of y equals x or whatever, do your derivative, set up this triangle. And that proves all those. I think on the homework, the last question, you have to prove it for cosine. So I did sine and tangent. You guys are going to do cosine. But like I said, these are given to you. I didn't even put them all on here. It's all on page 214. But we can go ahead and write them down if you want to have it on this notes handout. So the derivative of sine inverse we found to be 1 over square root of 1 minus x squared. The derivative of cosecant inverse is a negative 1 over x square root of x squared minus 1. Derivative of cosine inverse, which is a homework question, you are going to work this out, but we know what the answer is here. And like I said, I'm not going to make you memorize these. I'm not going to put them on a test or quiz. We really won't use them. If it ever does come up in a question, we'll just reference this table to look them up. So I want to do a couple problems just using these formulas, which is what most of those last few homework questions are, finding derivatives of inverse trig functions using these formulas. Okay, it's good there. Y equals 1 over sine inverse of x. 1 over is a negative 1 power. So this is like saying sine inverse to the negative 1. So if I asked you to do the derivative, we're doing chain rule. We start on the outside. So the negative 1 comes down. Inside stays the same. Times derivative of the inside. From our sheet, or from our table that we just wrote down, what is the derivative of sine inverse? Derivative of sine inverse is square root of 1 minus the angle squared. Okay, so we're just using the formula on this. And then as far as simplifying, I'm not going to require you to do a lot. I'm not going to say, oops, I dropped something. What did I forget? Yeah, I forgot to subtract 1 from my power. Okay. As far as simplifying it, not much we can do. If you want a sine inverse to the negative 2, that would move it to the bottom. I'm not going to make you move radicals off the bottom or really do much there. If you didn't put the sign on the denominator, I wouldn't count it wrong. So all we're really doing is plugging in with our formula. Remember, arctan is just another way of writing tangent inverse of the square root of x. So that's like x to the 1/2 power. So we have x times tangent inverse of x to the 1/2. So what rule are we going to have to use here? Product and chain rule here. So we have two things multiplied. We have an x times a tangent inverse of that. So product rule, derivative of the first times the second plus the first times derivative of the second. And this is the point where we're going to have to do our chain rule. So starting on the outside, tangent inverse. What is the derivative of tangent inverse? So you look at your table because I'm not making you memorize. Derivative of tangent inverse is 1 over 1 plus, and the x is because it's the angle. So it's 1 over 1 plus the angle squared. My angle here is x to the 1/2 squared. But what else do we have to multiply by? Derivative of the inside for the chain rule. So derivative of the x to the 1/2 would be 1/2 x to the negative 1/2. Alright, I know that got kind of ugly. Is everybody with me? When you use these formulas for the inverse derivatives, whatever your angle is takes the place of the x. So if it were sine inverse of 3x plus y, then in your formula it would be the 3x plus y taking the place of that. Okay, so as far as cleaning it up, not a ton we can do, but a little bit. And we could just rewrite this as tangent inverse of x to the 1/2. We have a 1/2 x times x to the negative 1/2, which is the x to the 1/2. And times this. What is x to the 1/2 squared? 1. So it's just an x to the first. Again, I've been pretty lenient on the amount of simplifying we do. If you wanted to, an x to the 1/2 is just a square root of x. The 2 would go on the bottom if you wanted to go this far. But that's about all we could do on this. I'm going to try a couple more. I'm going to add a couple extra, 1 or 2, just to make sure we've got it. Okay. What if I said find dy dx, and my equation is, y equals cosine inverse 3x to the 4th plus 2. Derivative of y is dy dx. We're going to have to do chain rule here, starting on the outside. So cosine inverse, the formula for cosine inverse is negative 1 over the square root of 1 minus my angle squared. And my angle is 3x to the 4th plus 2. So chain rule times derivative of the inside. What's the derivative of 3x to the 4th plus 2? And then as far as simplifying, that's really about all you could do. You could make it one fraction if you wanted. But that's fine. Last one. Let's say I gave you tangent inverse x cubed y equals 5x plus 4xy cubed. All right. Derivative of the outside. Derivative of tangent inverse is 1 over 1 plus the argument squared. So 1 over 1 plus x cubed plus, or x cubed y squared. Times the chain rule. So derivative of x cubed y. What would I have to do? Derivative of the first times the second plus the first derivative of the second. Derivative of y would be dy dx. Equals derivative of 5x would be 5. Plus, for this, we would have to do product. So derivative of the first times the second plus the first derivative of the second. Okay. Very ugly, for sure. If we distribute x cubed y squared would be x to the 6th y squared. What do we have to do? We need all the dy dx's on one side and everything without on the other. Would it bother you guys if I put these on the same side and factor out my dy dx at the same time? So if I take out the dy dx, this minus the 12xy squared. On the other side, we need all of these terms. final step is to divide. Technically, this is bad notation for our answer because we have a fraction and a fraction. And we could get rid of it, we know, by multiplying by the denominator. We've done that before. But I am not going to make you go that far. These problems, depending on where you stop with your simplifying, can get pretty lengthy. So even though this is super horrible notation, we could leave it like that. If you wanted to get rid of the fraction, you would have to take everything times 1 plus x to the 6th y squared on top and bottom and clean it up from there. So you're just going to end up with a few more terms, but we could do it. All right, that is probably the ugliest problem that I will give you. I think that's like problem number 17. Very, very similar to problem number 17 on your homework. Okay. So now you should be able to finish all the homework, so you have less time for it.
We need to do problem 17, right?
Yes. We skipped 17 yesterday because it had an inverse, but you can add it on to today's. So we talked about, I'll come back to this slide in a second if you guys need it, but today we have 17 and we left off at 36, right? So we have 6 problems to add on today, or if you don't have the other done, work on that. So it's all due on Monday.